Chapter 7, Section 4, Determining the Equation of a Line. So what we're going to do in this section is we're going to learn how to write lines. Previously what we did is you had an equation and you graphed the line. So now what we're going to do is we're going to have a description of the line conditions. Given conditions pertaining to a straight line, we're going to find the linear equation. So we're just going to go backwards. There are three different forms of an equation of a line that we will use, and you need to know all three of these. I would suggest that you put them on your index card. We have the point slope formula, which is going to be y minus y1 is equal to m times x minus x1. And we're going to use this to get to the other two forms. So slope-intercept form is y equals mx plus b. And standard form is ax plus by is equal to c. So your answers on the test, I will say put your answer in slope-intercept form or put your answer in standard form. So this point-slope form is just a formula that we'll use to get to the other two. Okay, so point-slope form. If you're given a point and you're given a slope, so you have a point and a slope, it's natural to use the point-slope formula because that's what it's called. And I told you what the point-slope formula was. Slope-intercept form, if you're given a slope and the y-intercept, it has to be the y-intercept. You can write an equation in slope-intercept form, y equals mx plus b. But to write an equation of a line, you have to know two things. You have to know slope and you have to know a point. If you don't know a point and you don't know a slope, you can't write an equation. You've got to know those two things. Once you know those two things, you can either use the point-slope formula or slope-intercept form if the point that was given is the y-intercept. You have to be given the y-intercept in order to use slope-intercept form. Alright, so a linear equation written in standard form will always look like this. Ax plus by is equal to c. Rules for standard form. These are the three rules that you need to know, because if I ask you to write it in standard form and you break one of these rules, I'm going to mark off. I'm going to count it wrong. Number one, x and y terms must be on the same side of the equal sign with the constant on the other side. So x and y, your x and y terms must be on the same side, and your constant, just the number, needs to be on the other side. No fractions, and a must be positive, so this leading coefficient must be positive. So, find the equation of a line that has a slope of 1/4 and a y-intercept of 2. And we are going to put this in standard form because we just talked about this. Find the equation of a line that has a slope of 1/4 and a y-intercept of 2. Well, notice you're given slope and you're given the y-intercept, which is b. So I can actually use slope-intercept form. Y equals 1/4 x plus 2. That's your slope-intercept form. So if I asked you to write it in slope-intercept form, you could stop here. But to get it to standard form, remember your three rules. Number one, x and y have to be on the same side. Number two, no fractions. And number three, your leading coefficient must be positive. So the first thing I think I want to do is get rid of the fractions. So we're going to multiply 3 by 4. Just multiply through that by that denominator. So we'll have 4y is equal to x plus 8. So now I need to minus x from both sides to get our x and y on the same side. So we have negative x plus 4y is equal to 8. And then I need my leading coefficient to be positive, so I'm going to multiply 3 by negative 1. So I'll have x minus 4y is equal to negative 8. And this would be standard form. So again, if I asked you to write it in slope-intercept form, you could just leave it here, y equals mx plus b. But if I ask you to put it in standard form, remember those three rules. X and y must be on the same side, no fractions, and your leading coefficient must be positive. Okay, write the equation of a line that contains the slope of 3/5 and contains the point 2,4. Notice this time I did not give you the y-intercept. I just gave you a basic point. So when I just give you a point that is not the y-intercept, you have to use the point-slope formula. So we have y minus y1 is equal to m times x minus x1. So the y is the y. Here is your x1, y1. Anytime you write a linear equation, you need x and y in your answer. So here's the y that's going to be in your answer, and here's the x that's going to be in your answer. Now, the y and the x that has the subscript, that's actually your point. So you have y minus y1, which is going to be 4, is equal to our slope, which is 3/5, times x minus x1, which is 2. Alright, and we're going to put this one in slope-intercept form. So we need to get y by itself. So we have y minus 4 is equal to 3/5 x minus 6/5. And then the only thing I need to do is add 4 to both sides in order to get y by itself, because slope-intercept form, y equals mx plus b. So y needs to be by itself. So we'll have y is equal to 3/5 x, and then in your calculator, negative 6/5 plus 4. Alright, so negative 6/5 plus 4 is going to be plus 14/5. And again, you can just put those fractions in your calculator. So again, that is slope-intercept form. Slope-intercept form. Now what if I asked you to put it in standard form? Well, we can go back to point slope. Y minus 4 is equal to 3/5 x minus 2. And just concentrate on what we need. We need standard form. We need x and y on the same side equal to some constant. So we're going to have y minus 4 is equal to 3/5 x minus 6/5. So that step's still the same, just getting rid of those parentheses. And now what I'd like to do is I'd like to get rid of those fractions. So I'm going to multiply through by that denominator. So we'll have 5y. So we'll have 5y minus 20 is equal to 3x minus 6. Now I need to get the x's and y's on the same side, so we'll minus 3x from both sides. And so I have negative 3x plus 5y minus 20 is equal to negative 6. So now I need to get this constant of 20 over here with this 6. So I have negative 3x plus 5y is equal to positive 14. And so this is still not standard form because I have that negative leading coefficient, so I need to multiply through by negative 1. So now what I'm going to have is 3x minus 5y is equal to negative 14, and that would be your standard form. So again, you can put it in either way that I ask. You need to be able to put it in either slope-intercept form or standard form. Okay, write the equation of a line that has a slope of negative 3/4 and passes through the point negative 8, negative 3. And I think I'm going to stop with slope-intercept form this time. So we'll have y minus y1, which is a negative 3. The minus, one of the minus signs comes from the formula, and the negative comes from your y1, is equal to our slope, which is negative 3/4, times x minus comes from the formula, and we actually have a negative 8 for x1. So we have y plus 3 is equal to negative 3/4 x plus, I think that's going to be just a 6. And then if I minus 3 from both sides, just to get slope-intercept form, I'm going to have y is equal to negative 3/4 x plus 3. And there's your slope-intercept form. Okay, so to find an equation of a line if given 2 points on the line. Remember I told you in order to write an equation you must know 2 things. You've got to know slope and you've got to know a point. So if you're given 2 points, the first thing you're going to do is find slope using that slope formula that we did in the previous section. And then you're going to take that slope and either one of your points and plug it into point slope. So let's try this. Write the equation of the line that contains these 2 points. So I've got 2 separate problems up here. The first one I want to do is slope-intercept form. So I'm going to find slope. The first thing for both of these, though, is to find slope. So we'll have y1, which is 0, minus y2, which is a negative 2, over negative 4 minus 3. So the slope either way is going to be 2 over negative 7, or negative 2/7. Okay, so if I go for slope-intercept form, I don't know what my y-intercept is, so I'm going to have to use point slope for both of these. So I'll have y minus y1, and I can use either point that I want to, and I think I'm going to go with this one, because the y1 is going to be 0 is equal to our slope, which is negative 2/7 times x minus x1. Oh, well, I know what x1 is. Let's plug in a negative 4. There we go. Alright, so we have y equals, because the 0 just goes away, and then if we do distribute through, we'll have negative 2/7 x. This goes to plus, so in all actuality, when everything's said and done with, it's going to be a negative 8 over 7. Now, in slope-intercept form, we can have fractions, so those fractions are not going to matter. Okay, so for standard form, we're still going to use that point slope, so we'll have y minus 0 is equal to negative 2/7 times x minus a negative 4, so we're still going to use the same setup. And then when we distribute, this again, the 0 is going to go away, but when we distribute, we'll have negative 2/7 x plus, well, it goes to plus, but then you have that negative, so it's going to be negative still 8/7. So this is slope-intercept form, so we need to take this and get it into standard form. So again, the first thing I want to do is get rid of this fraction. So I'm going to multiply through by 7. And so I'll have 7y is equal to negative 2x minus 8. Now then, to get the x term on the other side, I'm just going to add both sides by 2x. And so I'll have 2x plus 7y is equal to negative 8, and that is your standard. Write the equation of a line that contains these 2 points. So the first thing that I need to do is I need to find slope. So I'm going to have y2 minus y1 over x2 minus x1. So this is going to be 2 plus 4, which is going to be 6, and 1 plus 3, which is going to be 4, and that's going to reduce to 3 over 2. So I'm going to put this one in slope-intercept form. So here's my goal, y equals mx plus b. So I need to get y by itself, but I need to use point slope to get there because I'm not given a y-intercept. So we'll have y minus y1, which is going to be 2. I'm going to use this point here, is equal to my slope, m, times x minus x1, which is going to be 1. One thing that you need to understand is when you pick a point, you have to use both the x and the y. You can't flip-flop on me. Alright, so we're going for slope-intercept form, so let's get rid of those parentheses. So we'll have y minus 2 is equal to 3 halves x minus 3 halves. And then all I need to do here is get y by itself, so I'm just going to add 2 to both sides. And so we'll have y is equal to 3 halves x, which is going to be my slope, and then this negative 3 halves plus 2. We can put that in our calculator, and we're going to get a positive 1/2. And that is slope-intercept form. Now, slope-intercept form doesn't say anything about not having fractions, so you can have fractions in slope-intercept form. It's just standard form that you cannot. Okay, what if on the test I ask you to find slope and you're given the equation in standard form? Remember, in order to find slope, if given an equation, it has to be in slope-intercept form. Slope-intercept form, y equals mx plus b. Notice, if it's in slope-intercept form, m is the number in front of x, if it's in slope-intercept form. But if it's in standard form, which is the equation that we have here, notice you don't see a little m anywhere in standard form. So you can't tell me the slope for this equation until you put it in slope-intercept form. So let's solve for y. So we'll minus 5x from both sides. And we'll have negative 4y is equal to negative 5x plus 8. And then we'll divide everything by negative 4. And so we'll have y is equal to 5/4 x minus 2. And so now that it's in slope-intercept form, y is by itself, I can see that my slope is going to be 5/4. So make sure if I ask you a question like this, before you tell me slope, you have it in slope-intercept form. Okay, so the last thing we're going to do is we're going to graph using slope-intercept form. They save the best for last because slope-intercept form is the easiest thing to graph. When a linear equation in two variables is solved for y is by itself in terms of x, it is said to be in slope-intercept form. Y equals mx plus b. Alright, so you can graph the line directly from this form by plotting your y-intercept. So you're going to plot the point y-intercept, and it's going to be on the y-axis. Please do not get that confused. It's going to be on the y-axis. So you're going to plot your y-intercept, and then you're going to use your slope, rise over run, to find another point, and then draw the line between those 2 points. So let's try it. Here we have y equals 2x minus 3. Now here is your y-intercept, and here is your slope. So your y-intercept is basically 0, negative 3. And so to plot that, I'm going to find negative 3 on the y-axis. Remember, your y-intercept is on your y-axis. And then from here, from the point that I just graphed, we're going to use our slope of 2 over 1. If it's a whole number, just put it over 1. So we're going to rise 2 and run 1 and put our another point here. And then just draw your line. So if it's in slope-intercept form, all you have to do is plot your y-intercept and then use your slope. And if it's a whole number, put it over 1. So you'd rise 2 and run 1. Alright, let's try one more time. Here, your y-intercept is going to be 0, 1, and your slope is going to be negative 5 over 2. And we need to talk about that for just a second. This negative sign can either go with the 5 or the 2, so it can be written as negative 5 over 2 or 5 over negative 2, but it cannot go with both, because if it goes with both, they cancel out and go to plus. So that's a big no. It can either go with the top or the bottom. So when you plot 1 on your y-axis for your y-intercept, you can either go down 5 from your point that we just plotted. You can either go down 5, 1, 2, 3, 4, 5, and to the right 1, or you can go up 5, 1, 2, 3, 4, 5, and back 1. But the negative can either go with the top or the bottom. So just remember that, because if you go with both, it's going to be wrong. Okay, find the equation of the line that contains the point 1, 4 and is parallel to the line determined by this equation. Okay, so what we're doing is we're finding an equation, so don't stop until you have an equation of a line, and we're going to put it in standard form because the equation given to us was in standard form, but we need one parallel. So let's talk about parallel slopes. If you have slopes that are parallel, parallel slopes have the same, or parallel lines have the same slope. So if you have two lines that are parallel, they're going to have the same rise as the same run. Same rise and same run. So if this was 3 over 4, this would have to be 3 over 4. Parallel lines have the same slope. So, if I'm asking you to find an equation of a line that contains this point, but is parallel, that's telling you the slope. Parallel to the line determined, x plus 2y equals 5. You need to find the slope of the line given. So if we find the slope of this line, we have x plus 2y. It's got to be in slope-intercept form, so we would minus x from both sides. And then divide everything by 2. And so we have y is equal to negative 1/2 x plus 5 halves. So my slope is negative 1/2. And since my slope for this line is negative 1/2, then my slope for a line parallel is also going to be 1/2. So my slope is 1/2. And now that I know a point and a slope, I know the point 1, 4, and I know the slope 1/2, what I'm going to use is point slope. So we have y minus y1 is equal to our slope, which is negative 1/2, times x minus x1, which is 4. So, or 1. So we'll have y minus 4, distribute, so we'll have negative 1/2 x plus 1/2. half. And again, I want it in standard form, so let's get rid of those fractions. And I want it in standard form because the equation given was in standard form. So let's multiply 3 by 2. So we'll have 2y minus 8 is equal to negative x plus 1. And then standard form, I need to add x to both sides, and I need to add 8 to both sides. So these go away, and I'll have x plus 2y is equal to 9. And there you have it. So this line is parallel, parallel to this line because they have the same slope. But this line goes through the point of 1, 4. Okay, so let's talk about perpendicular lines. Lines that are perpendicular mean that they are at right angles to each other. So what that means is if this line has a slope that rises over runs, and let's say that it's 1 over 3, then this one is going to have a slope opposite of that. So it's going to be negative 3 over 1. So it'll have a negative slope. So if you have a slope that is 1/3, then the perpendicular slope, just drawn by perpendicular lines, perpendicular slope is going to be the opposite inverse of the slope. So let's look at this. It says find the equation of a line that contains the point -1, -2 and is perpendicular to the line determined by 2x minus y is equal to 6. So again, I have a point, I need to know a slope. So let's put this in slope-intercept form. So we'll have negative y is equal to negative 2x plus 6. Not quite slope-intercept. Let's multiply 3 by -1. So we'll have y is equal to 2x minus 6. So my slope for this line is 2, and that's not what I want. I want a perpendicular slope. So the perpendicular slope is going to be negative 1/2. Perpendicular slope is opposite inverse. Perpendicular slope is opposite inverse, which means opposite signs, reciprocal fraction, flipped fraction. So again, the line that was given has a slope of 2. Well, I want to know the perpendicular line to it, which is going to have a slope of negative 1/2. Opposite sign, inverse fraction. And it's going to have to go through this point, -1, -2. So now I know a point and now I know a slope. So I have y minus y1, which is a -2, is equal to my slope, which is negative 1/2, times x minus x1. So let's change these signs. Y plus 2 is equal to negative 1/2 times x plus 1. Alright, and again, I'm going to give the answer in standard form because the problem given was in standard form, or the equation given is in standard form. So we're going to have distribute. So you'll have negative 1/2 x minus 1/2. And then let's multiply 3 by 2. So we'll have 2y plus 4 is equal to negative x minus 1. Standard form, so we'll add x to both sides and minus 4 from both sides. So we'll have x plus 2y is equal to negative 5. And so this is your line perpendicular to the line given, but goes through the point -1, -2. So just remember that parallel lines have the same slope and perpendicular lines have opposite inverse. Alright, last one. Write the equation of the line that is A parallel and B perpendicular to this line, x plus 5y equals 9, and goes through the point 1, 3. So we have two different problems on this slide. We have A, we're going to find a line parallel, and then B, we're going to find a line perpendicular. So the first thing we need to do is we need to find slope. So if we have x plus 5y is equal to 9. To find slope, we've got to get it in slope-intercept form. So we'll have 5y is equal to negative x plus 9. And then divide everything by 5. And so we have y is equal to negative 1/5 x plus 9/5. So here is your slope. There's your slope, negative 1/5. So if I find a line parallel, I'm going to use the same slope that I just found in the line given, which is negative 1/5, and I have a point of 1, 3. So we'll use point slope. So we'll have y minus y1, which is 3, is equal to negative 1/5, which is my slope, times x minus x1. And again, I'm going to put it in standard form because the equation given was in standard form. So we'll have y minus 3 is equal to negative 1/5 x plus 1/5. Standard form, let's get rid of those fractions. Multiply 3 by 5. So we'll have 5y minus 15 is equal to negative x plus 1. And I need to get x and y on the same side, so I'll add x, but I need to get this constant on the other side, so I'll add 15. So I'll have x plus 5y is equal to 16. So this one is parallel. Now let's do perpendicular. So parallel slope is the same, so that's negative 1/5. Perpendicular slope is going to be opposite sign, so it's going to be positive, and flip fraction, which is going to be 5. So the perpendicular slope that I'm going to use is 5, and I have a point of 1, 3. So let's put this in point slope. We have y minus y1 is equal to m, which is 5, times x minus x1, which is 1. And again, I need this in standard form, so the first thing I'm going to do is get rid of those parentheses, so we'll have 5x minus 5. And then I need to get x and y on the same side, so I'll minus 5x, and I need to get the constant of 3 over here. So we'll have negative 5x plus y is equal to negative 2, but I can't have a negative leading coefficient, so we'll multiply 3 by negative 1. So we'll have 5x minus y is equal to 2. So this one is your perpendicular line. Alright, so what I'd like you to do is I would like you to attempt these problems on page 383. Bring them into class if you have any problems.